So by this time, scientists had a really good idea of what the model of the atom looked like. And as you can see, it's actually the same idea we still have today. The protons and the neutrons are condensed into a really tiny spot in the center of the atom. And then the electrons sort of hover around the nucleus very, very fast. So you think of electrons as obviously a lot smaller than protons and neutrons, and they're whizzing around really fast, sort of like bees hovering around a sweet flower. Don't think of them as just, how people draw them on paper. They're not static. Electrons are always moving, okay? Sort of like waves are always moving. So you have this small little condensed little packed nucleus, and then you've got these electrons hovering, whizzing around really, really fast. So now that we have a pretty good idea of what the atom looks like, we can start trying to identify them. We can identify atoms by their number of protons and neutrons they contain, all right? So the atomic number, which we're going to signify here as Z, basically tells us the number of protons. The mass number, which we're going to signify as A, tells us the number of protons plus the number of neutrons. The number of protons is also called the atomic number, so think of that as the name of the element. So how can I identify you? I identify you by your name. You are only your name, right? You're not somebody else's name. So that's how we identify atoms. No two atoms can have the same number of protons. And remember that atoms have the same number of protons and they have the same number of electrons, so those stay the same. But what's the thing that changes? The thing that changes is the amount of neutrons, like we learned in the last video. So atoms of the same element that have different number of neutrons are called isotopes. So as an example, I've included the 3 isotopes of hydrogen. Hydrogen all have 1 proton because, of course, that's its name. So the only difference here is that how many neutrons do these 3 isotopes have. The regular hydrogen, the one that's most abundant, is called protium. So it has 1 proton, okay? Now remember, the proton is the letter Z, which would be the bottom number, and it has 1 electron. But we don't say electrons because it's sort of understood. Since you have 1 proton, you're going to have 1 electron. So those we don't signify in the letter symbol. The number on top is what the mass number is. So basically the number of protons plus the number of neutrons. Protium doesn't have any neutrons, so the number of protons would be 1, the number of neutrons would be 0. So that's why there's a 1. If we look to the next example, deuterium, we have hydrogen still having 1 proton, that's the number 1 on the bottom, but then the mass number is 2, and that's because it has 1 proton and it has 1 neutron. So 1 proton plus 1 neutron equals 2 for the mass number, and that's why there's a 2 up there. Can you tell me why tritium has a 3 on the top and 1 on the bottom? You better learn how to do that because you will be doing that in recitation. As another example, we have uranium, which is a radioactive compound, but uranium has how many protons? We know by now that the number on the bottom signifies how many protons it has, and basically its name. So it's 92 protons. So how many neutrons does uranium-235 have? What you would do is you would take 235 minus 92, and you would get 143. So uranium-235 has 143 neutrons. So a good exercise for you would be to tell me how many protons, electrons, and neutrons does uranium-238 contain. To make sure that you understand this concept, try to answer this question. What is the atomic number of an element if one of its isotopes has 117 neutrons and a mass number of 195? So basically you need to find the number of protons, and with that number of protons you will find out what element it is. Section 2.4 talks about the periodic table, and I'm showing you here what the modern periodic table actually looks like. More than half of the elements known today were discovered between 1800 and 1900. During that time, chemists started to notice that many elements showed a lot of really strong similarities to one another. So they were trying to figure out, how am I going to put, all these things into a nice, concise table? At the beginning, the periodic table did not look like this. But once they started recognizing the regularities or the similarities of some of the elements, they started to put them together. Some of the periodic regularities are in the physical or chemical behaviors that they saw, but all that available information helped to structure the modern, what you're looking at now, which is the modern periodic table. In this table, the atoms are arranged by atomic number, and we learned what atomic number was in the last video. That tells us how many protons each element has. So hydrogen would have 1 proton. If you go all the way to the right, that's helium. Helium has 2 protons, and you keep reading from left to right. So if you notice, number 112 all the way on the bottom would have how many protons? 112 protons. So they're in order of atomic number. Now the horizontal rows are called periods, and the vertical columns are called groups or families. And the reason that they're called groups or families is because everybody that's lined up in the same column has the same chemical properties. And we'll learn that very carefully throughout the semester. But for example, the first row, which has hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, all have same chemical properties, and that's why they are all on the same row. So elements can be divided into 3 main categories: metals, nonmetals, and metalloids. You should know a metal is a good conductor of heat and electricity, while a nonmetal is usually a poor conductor of heat and electricity. And a metalloid, which is these guys right over here, has both properties. They're kind of like in the middle, right? A metalloid is in the middle of a metal and a nonmetal. If you can tell, most of the elements are metals at standard temperature and pressure. There's certain groups that you should be very well accustomed to by the end of this chapter. The first group is the alkali metals, and that's the first column that I read off to you: hydrogen, lithium, so on and so forth. Those are called the alkali metals. Alkali metals are usually very reactive. They're malleable and shiny metals. Group 2, which is the second column, beryllium, magnesium, calcium, strontium, so on and so forth, those are called alkaline earth metals. Those are not as reactive as group 1, but they are also sort of shiny, but not as brittle, more brittle, not as malleable as the first group. Then group 7, so basically what I'm doing is I'm counting 1, 2, 3, 4, 5, 6, 7. For right now, we are going to not talk about these metals right in the center, which are called transition metals, because they're a little bit more complicated. So we're going to concentrate on just rows 1, 2, 3, 4, 5, 6, 7. Column 7, I keep saying row, but column 7 are called halogens. Okay, fluorine, chlorine, bromine, iodine, so on and so forth. The word halogen is a Swedish word that means come to be salt. So halogens, when they react with a metal, they make salts, and that's why they're named halogens. At standard temperature and pressure, halogens are all states of matter: liquid, gas, and solid. In column 8, we have the noble gases: helium, neon, argon, krypton, xenon, radon. These are all colorless, odorless, monoatomic gases, and they're not very reactive. I didn't mention this about column 7, the halogens, but they are very, very reactive. Column 8, not so reactive anymore. Okay, they are elements that have a full octet, which might not mean a lot to you right now, but it will by the end of the semester. So they're full, and they're not hungry anymore. They don't react because they have everything they need, and that's why they're called noble gases, or inert gases are what people call them more often now. They're inert because they don't like to react with anything else because they don't need to. So you will be responsible to understand how the periodic table is organized, where the alkali earth metals are, where the alkali metals are, where the halogens and noble gases, and where the transition metals are. And we didn't talk much about those, but they're mainly in the center from here to here, and also including these down here. You will be responsible for knowing the organization of the periodic table. So make sure that you read up on the short section of 2.4. The next video will discuss molecules and ions, section 2.5, and we're going to also talk about chemical formulas, 2.6. See you then.